Hi folks, you're watching the MATLAB and Simulink Racing Lounge. In today, part 4, in the final part of our vehicle modeling series, we're going to talk about 3D simulation, and I'm glad that Ed is still on board. Hi Ed.
Hi Christoph, how are you?
Oh, not too bad. How about you?
I'm doing great, thank you.
Cool. So let's do something differently this time. Let's jump to our software demo right away and see the visualization that we have prepared for you.
Absolutely. All right, so this is the demo that we have prepared for you today. And what we can see is that we have a 3D environment for visualization of our system. And what I have here is a full vehicle model that actually includes the suspension dynamics. And you can see how it performs with a specific driving maneuver there.
Nice word for a donut. And I think this is the point where we're leading over to our topics of today. So why is that the coolest thing? What are we going to talk about today?
We're going to talk today about Simscape Multibody. In the 3 previous episodes, we have covered different modeling techniques like Simulink, Powertrain Block Set, and also Simscape. And each one of those uses a different approach, for example, equation-driven or data-driven. But today is still in this physical modeling environment, but we're going to add the 3D visualization component to it today.
I see. A quick question, and please try to answer it briefly. What is the main difference between Simscape and Simscape Multibody?
So they're in the same environment, but the difference is visualization.
I see.
3D environment.
Okay, perfect.
Excellent. So Multibody, as I mentioned, is an extension to the Simscape family of products. And it enables us to model 3D mechanical systems. And so, for example, if we take this pendulum, and I actually model that in Multibody, this is what my model looks like. And also, this is the animation that I get with it. So what you can see here is that we can build this model using bodies, joints, forces, and the structure of my model actually resembles the structure of my system as well.
Okay.
And just like other Simscape products, there's no need to derive or program equations. All of these are taken care of by Simscape.
Just to summarize for you guys, basically what you're modeling in Simscape Multibody is actual 3D components. You're modeling the geometry, you're modeling the interfaces between them. So for example, for a pendulum, it's a certain rotary joint or rotational joint. And basically, Ed pointed it out already, you're getting for free, without extra modeling effort, a 3D visualization.
Absolutely. All right, so some of the primary uses for Simscape Multibody can be system-level analysis. And what that means is that we can generate engineering data to assess a system and then select the architecture that best meets our needs or our requirements.
Nice.
We can also use Multibody for control development in Simulink. It actually integrates very easily with the Simulink environment.
I see. Yeah, an example for that is basically Simscape is using the same user interface as Simulink. And well, a lot of guys, we know that, are modeling control systems in Simulink. So these two worlds are basically one world. It's the same environment.
Absolutely. All right, so one of the features that I like to call this a feature for Multibody is that we actually have training for Simscape Multibody that is geared toward student competitions. And we can access that training by going to that link or by doing an online search for MathWorks student competition training as well.
I see. Yeah. Cool. Quick comment at that point. We even see it as a prerequisite to go through the training first, because the model that we're going to show you, we will put it on File Exchange for sure, but working with the model requires some skills about Simscape Multibody. So do yourself a favor, go through the training thoroughly if you want to focus on that, because you will save a lot of time later on when actually debugging the models and further advancing the models.
Absolutely. Those are 2 great points. I think the first recommendation is to go check out that training, become familiar with the product and the environment. And the other comment that you mentioned was we're going to make this model available, so don't worry about trying to recreate anything during the video. Just sit back, relax, and then you'll be able to play with this later on once we provide the model as well.
Nice.
All right, so now on product features, actually, Simscape offers the ability to model and create your own rigid bodies with standard extrusions, but also with custom extrusions that you can create from MATLAB. And the cool thing here is that Simscape actually can calculate the mass and the inertias from those geometries that you create. Also, Simscape can be easily reused in models, in other designs, and what I mean by that is if you have a part, you can simply copy-paste if you would like to reuse that in the same model and do the appropriate transforms. Or if you have a full model in Multibody, you can actually integrate that model with other Simscape components or Simulink components as well.
Right. Simple example for that is you model one wheel, you copy and paste 4 wheels.
That's correct. Yep.
Quick question about CAD. I think, okay, you're already answering it, because my question would have been, is it possible to import CAD geometries? Because a lot of teams are working with a certain CAD systems.
Absolutely. And that actually leads to my next point. I think we have a video from the MATLAB and Simulink Racing Lounge on how to do import of CAD assemblies to Simscape Multibody. And this can be done with the Simscape Multibody link, or it can also be done by simply bringing STL or step files into the Simscape environment.
Yeah, and there's an online CAD platform that has a nice connection to Simscape Multibody. It's Onshape. But again, if you Google for CAD import Simscape Multibody, you will find all the relevant stuff there.
Absolutely, and the link to that video is actually in the description.
Perfect. Yep.
All right, so another advantage is you get 3D animation of the simulation results, again, with no effort. Simply put your model together and then the animation will come up.
I see.
And you can also connect Simscape Multibody to other control algorithms and other physical domains, whether it's in Simscape or Simulink. Now, how can we use Simscape Multibody for vehicle modeling? One of the things that we can do is model the dynamics of mechanical systems. In this case, we can model a suspension, and we're going to also show how to model a full vehicle here. And we also have a MATLAB and Simulink Racing Lounge video on how to do design optimization for a suspension system. So you can also find the link to that video in the description.
Yeah. I think this is a pretty nice use case. You have a full vehicle model, fully parameterized in Simscape Multibody, and then you can use all the nice optimization tools that MathWorks provides. But you already pointed it out. It's not exclusively about optimizing a suspension design. It's optimizing any designs where you have access to the data.
That's correct, yep. Another important point is that Multibody gives you the ability to model contact between 3D shapes. And we can do this with the contact forces library, which is in the MATLAB Central file exchange.
I see.
And so an important point on contact, why do we care about contact? And the point here is that contact is not a trivial thing to model, and this contact forces library interface allows you to do all the complex math of contact with a solution that is out of the box. You simply use these blocks, and they're relatively simple to learn as well.
Yeah. A comment at that point, so by default, Simscape Multibody does not come with contact, and that's for a reason, because modeling contact takes some CPU resources, and if you don't need to model contact, well, you can save some CPU time by not modeling it. But, well, certainly, we will have a car driving on a track, so contact, friction, tire behavior is important. And the good thing, again here, Sebastian and you have created a nice resource. It's a blog post about contact modeling where we give you the opportunity to explore the details and the theoretical background.
Absolutely. Let's take a look at that blog. So this is the blog that was created, again, part of the Racing Lounge, and here we're introducing different approaches to contact, how to do it with Simulink, but the important focus here is how to do it with Simscape Multibody using the contact forces library. And we give you the background theory that you need to understand all of these different approaches. We give you several examples using Simulink, Simscape, and different tools. And we also have 2 instructional videos for applications of contact in the Simscape and Simulink environments.
That's perfect. So instructional videos means they are same style as Racing Lounge videos, and you will find all relevant models on the file exchange. So I think that's for you guys who want to be involved more about the contact dynamics. We have plenty of material for you. That's a good message.
Absolutely. So the last point for Simscape Multibody and vehicle modeling is that we can actually visualize the system response in 3D. And there's an advantage to Multibody here because we can customize the way we want to look at that response by implementing cameras in the Mechanics Explorer. And I'll touch on that once we dive into our demo.
I think an important keyword for the visualization is visual debugging. You can make sure that your model is set up physically correct by just looking at its behavior. And sometimes the engineering intuition is a powerful tool just to look at something and see whether it's right or wrong.
That's right. All right, so let's dive into our demo now.
Demo time. Very good. Very good.
All right, so what we see now is the way that we implemented this model in the Simulink environment. And let's see what happens if I run this model. All right, so once I play this model, this is what the response looks like. And you can see that I implemented a driving maneuver called a slalom, kind of like a snake shape. And this is actually the behavior that we're seeing from my vehicle system as well.
But now the key question is, how can you model that system? What is the background?
Absolutely. Let's take a look at the Simulink canvas now. So this is what the Simulink canvas looks like. And here at the left, to the left, I have a subsystem called inputs, but I also have some dashboard instruments that allow me to drive the model in manual mode if I desire. And the way to set that manual mode is here in this mask. I can set the dashboard instruments, but you can see here in the input subsystem that I have different maneuvers, like a slalom, which we just saw, or a right turn, a left turn, a burnout, kind of like a donut, or also a skid pad maneuver.
Yeah, and just to be frank here, the maneuvers is a nice way of just summarizing or wrapping around some combinations of throttle and steering. So behind each driving maneuver, you have a certain combination of using the throttle and brake plus the steering.
That's right. Excellent. Also here, if you look at the right of the model, we have different dashboard blocks that output certain signals of the model, give me some information right away. So what I can see here is the vehicle speed in kilometers per hour, also the vehicle roll in degrees, or the vehicle heading also in degrees.
Quick question at that point. Is it the only signals that we can get out of the model? Or what would I do if I want to optimize, for example, roll center or very specific components like damper travel?
You have more data available than what I'm showing here with these three dashboards. And that's a great point because I'm also doing some logging with the simulation data inspector. So to answer your question, if you want to optimize certain parameters here, all you have to do is find those signals in the model, and you can do Simulink design optimization and things like that to those signals as well.
I see. Okay.
All right. So to the point of data logging, I'm actually going to run a steering input of 90 degrees to the right, and we'll actually see what the model response is from log data as well.
Perfect. That's good. Mm-hmm.
So now we're driving with an input of 90 degrees to the right, and you see I'm going in a straight line, and now the vehicle is turning, and that was a pretty successful turn, I would say, there. So if we go back and we take a look at the simulation data inspector, you can see that I'm logging several signals here.
Okay.
So we can take a look, let's say, at the front left suspension travel versus the front right suspension travel. And you can see as I'm turning right here, you can see the effect of the weight displacement in the suspension. So as you would expect, the front left dips down and the front right kind of moves up based on the weight shift.
Okay, so basically what I'm seeing is we have access to all mechanical quantities. They are MATLAB variables in the workspace, and we even can use the Data Explorer to visualize them for quick visual debugging.
Exactly. So there's a lot of power that you can do with the things that you can do here. All right. So back in the model canvas, you can see here I have 4 wheels, and each one of these wheels is modeling contact between what I call a sphere and also a plane. That's the interface that we're using from the model, from the contact forces library. So let's take a look at that. If I go under the tire subsystem, the front right wheel, we can see this front right wheel contact. And that's where I'm actually implementing the contact with the contact forces library. So you can see that this is just a block. We don't really have to do equations or anything like that. These blocks are already created for us, and all we have to do is connect the different frames that we want to model contact between.
Okay, so you already answered the question I was about to ask. The block that we're seeing here in the center of the model is available with this library on File Exchange, and it's only a matter of connecting it correctly in our model.
That's correct. And also, one of the things that you can see here is that it has an output bus that actually contains different signals based on the calculations that are done in the block. And you can take a look at those signals later on for processing and things like that.
Okay.
Excellent. So that's how I'm modeling contact for all the 4 wheels and the plane as well.
Nice.
Another thing that I want to show is pretty much how we're doing the body geometry. And what I did for that vehicle body, the green body that we saw in the animation, is I'm simply bringing a step file from my CAD software into this vehicle body. And that's how I'm bringing that geometry into Multibody.
Yeah. Well, that's a very nice example. And well, teams watching that video, feel encouraged to upload or import your own CAD geometry of your chassis. I think that creates a lot more fun when working with that simulation.
Absolutely. And another point that I have here is the cameras. We talked about visualization and how to customize that visualization. So what I'm doing here is I'm defining different frames to place my cameras. And that gives me the ability to choose how I'm going to look at the simulation response in the Mechanics Explorer, in that 3D environment. So what I'm doing here with this Revolute joint and this physical integrator is placing the camera that actually moves with the vehicle, as we saw in the animation.
Nice. Okay, so even 3D visualization is a powerful tool. So there's something at the bottom right of the model, which is kind of a scope displaying results. What's the background story of that?
That's a great point. I'm glad you asked about this block, and the purpose of this block is to show the trajectory in X, Y coordinates, the trajectory of the vehicle, that is. So if I change my driving maneuver, let's say, to a skid pad, we can see how the points that our vehicle is going to cross in space. So if I run the model now, this is the response that we get from the model when we run with a skid pad input. And in the right, you can see the vehicle response in 3D, but here on the left, you can actually see the trajectory. It looks like an H shape, kind of what we would expect from a skid pad input.
I see.
Another thing that I would like to talk about in this model is the ability to run in a manual mode. And the point for this is if one of the driving maneuvers that we have made available doesn't cover what you want, then you can drive with the dashboard instruments, kind of like in manual mode, or you can also choose to implement your own driving maneuver into the input subsystem. So I'll give you a quick demo on how to run with the dashboard instruments. So here in the left, we can see that we have the model. In the right, we have the 3D visualization or the animation of the model. So if we want the model to go, let's say, at 25 kilometers per hour, we can see it there picking up some speed. And right now, I don't have any steering input. So let's say I want to turn right. I can go ahead and give it some steering input. And you can see there that it actually starts turning right. And I can do the same thing if I want to go left.
I think the main point here is just to stress that it's for visual debugging. You can check your car's behavior. We are certainly, or our intention is certainly not to have a play or a gaming engine for you to train your drivers. I think it's a nice way of debugging visually. And as Ed already pointed out, I think driving maneuvers can also be implemented by, well, using the stuff we've introduced in videos 1 and 2. We worked with drive cycles, and for that model, well, right now it's a vehicle model, but as Ed pointed out, you can embed it into a Simulink environment, apply drive cycles, apply controllers, have drivers, so you can build a full-fledged vehicle simulation with that as a starting point.
Absolutely, and yeah, that's the point here. We want to provide a starting point for the users to later on utilize and build on top of this as well.
Nice. All on File Exchange, we said that already. Start from there and make sure you take the training first.
That's right. Now it is time for some key takeaways so we can wrap up our episode. And the key points here are that Simscape Multibody allows us to model mechanical systems, and the advantages that we get a 3D visualization of the response as well. And let's not forget that Simscape Multibody is part of the Simscape product family. Therefore, it extends the capability of the Simscape environment.
Right, and Simulink as well. It's the Simulink user interface you're using.
That's correct, yep. So again, we mentioned that multibody can be used for system-level analysis, where we can generate some engineering data to assess our system and select the best architecture of that system to meet our requirements or our needs. In this case, we used it for analyzing suspension dynamics.
Right.
We can also model contact with the contact forces library.
Yeah. Well, at that point, two comments. Analyzing suspension dynamics is one of the examples you could do. It's a convenient example for vehicle dynamicists, but you can use it for anything. And also the design optimization we talked about, it's not exclusive to suspension dynamics. And contact, well, contact is a tricky thing, but we've provided you all the tools. Well, to go into the details, we've provided you with a lot of links and references. So have a look at Ed's blog post. I think that should close the loop and give you the bigger picture of contact modeling. I think at that point, we are at the end. We have not only wrapped up video number 4, we are about to wrap up the full series of vehicle modeling. So 4 videos full of powerful demos, full of powerful models that you can download, plus the videos. So I think there's something for you to go through. Make sure it's beneficial for you and make sure to use the right tool. So it's a thought process of choosing the right tool for your applications. Ed, my sincere thanks for working with me on that vehicle modeling series. I hope it was a bit of fun.
Oh, absolutely. It was a lot of fun, and I'm glad that I was part of this effort to show how to do vehicle modeling with different platforms.
Well, for the last, let's say, 3 or 4 months, it's fair to say that you were Mr. Racing Lounge. Jose and you basically ran the Racing Lounge with doing videos about our nice demos, the RC car, with doing the vehicle modeling series. So thanks very much. And I think this brings us to the end of that episode. Thanks, Ed. Thanks very much.
Absolutely. It was my pleasure.
Perfect. And last but not least, guys, we are heavily relying on your feedback. So please send us emails or comments in the Facebook group. If you want to check out more videos of the Racing Lounge, go to mathworks.com/Racing Lounge. And well, if you want to check out the software offer that we have for Formula Student and a lot of other student competition teams, check out the links as well. And if you do use our software, we would be super happy if you use the MathWorks logo on your car, on your reports, or on your materials in general. At that point, thanks for watching. See you next time. And really, we are hoping for your feedback. Thanks very much.
Bye-bye.